In this video, let's study about eigenvalue and eigenvector. Geometrically, an eigenvector corresponds to a real non-zero eigenvalue, points in a direction in which it is stretched by the transformation, and the eigenvalue is a factor by which it is stretched. If you see the definition, the eigenvalue of a matrix A is a vector represented by a matrix X such that when X is multiplied with A, then the direction of the resultant matrix remains the same as the vector X. That is, you see this equation Ax is equal to lambda X, where lambda is the eigenvalue and X is the eigenvector. So basically, when you process a given set of data, these eigenvalues and eigenvectors helps to find the set of important variables along which scale, along which direction, and all those things. There are many applications, and this is one of the important and interesting application, that is the Tacoma bridge. You can go through the videos in the net. So you can see that oscillation is too much in the bridge and it got collapsed. So the main theory is based on natural frequency and resonance. What do you mean by resonance? This is nothing but the natural vibration that the bridge experiences. So here what happened, the natural frequency was close to the surrounding winds which caused the bridge to oscillate too much, and finally the bridge got collapsed. So based on the system of equation, the bridge was modeled after the natural frequency, that's the eigenvalue of smallest magnitude oscillation. So using eigenvalue and eigenvector, we can prevent such disasters. So this is one of the application of eigenvalue. Okay. Now let's see this problem. Find all the eigenvalues and the corresponding eigenvector for the given matrix. So this is the given matrix. So I'm just taking this as A. Okay. So first row. So this is the first row. 8 minus 6 minus 2. Second row is minus 6, 7 minus 4. And third row is minus 2, minus 4 and 3. So step 1. We are going to find the characteristic equation of A. Okay, so how to find the characteristic equation? This is nothing but modulus of A minus lambda I is equal to 0. So this is the equation. And if you see here, the diagonal elements 8 minus lambda, because I is nothing but the identity matrix. If you multiply lambda with the identity matrix, only the diagonal elements will be there, 1, 1, 1. Right, so identity matrix contains 1, 1, 1, and if you multiply with lambda, the diagonal elements will become lambda. And finally A minus lambda I. What is the A value first? 8 minus lambda. Again second one 7 minus lambda, then the third value is 3 minus lambda. So the diagonal elements we filled it. So the rest of the elements will be the same. So minus 6, minus 2, and then minus 6, minus 4 here, and then minus 2, minus 4. So only we are disturbing the diagonal elements. A minus lambda means whatever value is there, just put minus. So now we have to find the determinant value. How to find the determinant value? So leave the first row and first column, that is 8 minus lambda into 7 minus lambda into 3 minus lambda, this into this minus. Correct? So now we got this, that is modulus of A minus lambda is equal to 0. So sorry, not modulus, that is the determinant. So how to find the first determinant? It's like first we'll write 8 minus lambda. So leave this row and this column. Multiply these two. Okay, 7 minus lambda into 3 minus lambda I have written. And then put a negative sign and then multiply these two. Minus 4 into minus 4 plus 16. Already we have negative sign in the formula. Then 8 minus lambda I have written. The second component minus of that value you have to write. Already minus 6 is there. Minus of minus 6 it became plus 6. Now you are going to leave that row and that column. See here 6 row is here and 6 column is here. I have cut down these two. So what are the leftover elements? Minus 6 into 3 minus lambda. I have written this. Then minus 2 into this value. 2 into minus 4. 2 into minus 4 is plus 8. And finally we have the last element plus 2. So I have written plus 2. So where first element minus second element, then third element. So this is what we are doing. So plus 2 into, if I leave this row and this column, for example, I'm taking this color, just leave this green one, minus 6 into minus 4. So this is going to be plus 24, and then minus 2 into 7 minus lambda. So we have written that is equal to 0. So simplify it very carefully and you will get this equation: minus lambda cube plus 18 lambda square minus 45 lambda is equal to 0. First term I don't want negative, so I'm just changing the sign. So this is a cubic equation. So how many roots you will get? 3 roots we will get, and you can solve this. And you can solve by synthetic division. There are many methods. So I have taken lambda common. So the rest of the values here. So one root is lambda is equal to 0, and the second root is the roots of this quadratic equation. Correct? And this value is 45. You can use T method. You can write down these two values here. Okay. So I have to write down two values. If I multiply, I should get plus 45. And if I add, I should get minus 18. So what are those values? That is minus 3. And what is the next root? Can you guess? Minus 15. So if I multiply, I'm getting plus 45. If I add, I'm getting minus 18. So here I can write this as lambda minus 3 into lambda minus 15 is equal to 0. So lambda is 0, 3, 15. So this is the cubic equation, and we got three values. So these roots are called eigen values. Oh my god, what am I writing? Are called eigen values, or we can call it as a characteristic root. And this is nothing but the characteristic polynomial, and these are the characteristic root or eigenvalues of the given matrix A. So we are done with eigenvalue. We are going to find the corresponding eigenvector for this. So now we have the system of equation here. So how we got the system of equation? Remember when you wrote the characteristic equation, the first term was, let me use this color, first term was 8 minus lambda and then minus 6 minus 2. So 8 minus lambda into x minus 6 into y, then it was plus 2, right? Plus 2 into z. And second row what we had, minus 6 and 7 minus lambda and minus 4. Correct? So minus 6 into x, I have written this, plus 7 minus lambda into y minus 4z. And third row we had 2 minus 4, 3 minus lambda. So minus 2x minus 4y plus 3 minus lambda into z is equal to 0. So this is your master equation. Basically what you are going to do is, you have 3 lambda values, right? So case 1, first what is the easy one? We'll take lambda 0. We'll substitute here. We will set we will get system of equation, that is 8x minus 6y plus 2z is equal to 0. I have substituted lambda 0. Second equation, minus 6x plus 7y minus 4z is equal to 0. Third equation, minus 2x minus 4y plus 3z is equal to 0. We are going to solve these and we will find the x values, right? So this is your corresponding eigenvector for the value lambda is equal to 0. Similarly, we are going to substitute lambda as 3, and then you will get another set of equation. You're going to solve it and find x, y, z. So substitute lambda as 15, again another set of equations, find x, y, z. So I'm going to solve this. There are many methods. I'm going to solve this by the method of cross multiplication. So basically what I'm going to do is, if I have written x, okay, so I'm just going to leave that x column. Okay, I'm just going to mark that x column in red. So leave this, okay. And what are the leftover elements here? Minus 6 plus 2, 7 minus 4. Okay, so what I will write here is x divided by modulus of minus 6 to 7 minus 4. Okay, and then when I write y value, I will put minus y in the numerator. Okay, then there will be equal to here, sign here, minus y I will write in the numerator, and in the let me take another color. Yeah, so now I'm going to mark this in green, the y coefficient. So it means I'm not going to touch this. What are the leftover values in the first two rows? 8 plus 2. I've marked in green. See here, 8 and plus 2. And then the next one is minus 6 minus 4. So the next determinant is 8 to minus 6 minus 4. Oh my god, it's going really cross, and equal to z by. Let me take this color, yellow color. I'm just going to mark this z. It means I'm not going to use this. What are the leftover coefficients? 8, minus 6, and minus 6, 7. So I'm going to write 8 minus 6 and minus 6, 7. Let me write this neatly in the next slide. Every time I'm trying to write neatly, but still it end up coming like this. Okay, so this is what we wrote. Remember this carefully when you apply the rule of cross multiplication. So for the first two equations only we did. So x, and then here we'll write minus y and then z. Okay, if x means I left x column and took out the coefficients from the first two equations. And now it is determinant minus 6 into minus 4, 24 plus 24 minus 7 into 2. So this is nothing but 24 minus 14. So I have written 10 here. Okay. And then here 8 into minus 4 minus 8 into minus 4 minus minus 6 into 2. Okay. So because of the negative sign, this first term will be minus, second term will be plus. Okay. And so we get minus 32 plus 12, and we've got a negative sign in the numerator here. So this is denominator, though it is minus 20, because of this negative sign became plus 20. And the third one, 7 into 8, okay, minus 6 into minus 6. So it is plus 36. This will become, please be careful with the calculations. So you are getting 20 here. So these are the values. If I simplify it, x by 1, y by 2, z by 2, because it's a multiple of 10, right? So if I substitute x as k, y is nothing but 2k and z is also 2k in this case. So the x1 values are 1, 2 and 2. Okay, so this is the eigenvector corresponding to the eigenvalue 0. So now we can go really fast, because case 2 we are just going to substitute lambda is equal to 3 in equation 1. Remember what we had, the first term 8 minus lambda into x. So 8 minus 3, that's nothing but 5x. Then these are all same, minus 6y plus 2z, done. Second row also minus 6x, same. Here you remember 7 minus lambda was there. So 7 minus 3, 7 minus 3 is 4. And this term is the same, 4z, leave it, 2x same, minus 4y same. And this term you remember 3 minus lambda, only the changes will happen only in the diagonal elements if you notice. So 3 minus lambda, that is 3 minus 3, 0z. And we have 3 equations, and we are going to find x, y and z by the method of cross multiplication. So I have written plus x, minus y and plus z. Remember what we did for x, leaving that x column, I've considered only the first two equations. What are the coefficients? Minus 6 plus 2, minus 4, minus 4. So it's a determinant, right? So minus 6 into minus 4. So 24. This is what we have written. And then minus 4 into 2. 4 2s are 8. Same way, minus y. Let me take another color, green. So this is your y coefficient. Leave your y coefficient as it is, y column. And only first two equations we are just going to consider. So follow the green color. So leaving y, what are the first values? 5, minus 2, and then minus 6, and then minus 4. Correct? So cross multiply 5 into minus 4. So minus 20 we have. Same way minus 6 into plus 2. Okay. So this is minus, right? First two values minus second value. So 5 into minus 4 is 5 into minus 4 is minus 20 minus 6 into 2. So minus 12 we will get. So that minus and this minus will become plus. And finally Z, and what we had leaving this Z column, let me use some blue, leaving this, oh my god, it's not visible. Leaving the Z column, what are the other two coefficients? That's horrible. So 5 minus 6 and minus 6 4. Oh, this is the determinant. So 5 fours are 20 minus 6 into minus 6. So minus 36. So this will become plus 36 because of the minus we have here. So finally when we simplify, what we are getting, x by 16 is equal to minus y by minus 8, then y by plus 8 we can write is equal to z by minus 16. So if I simplify this, x by 2 is equal to y by 1 is equal to z by minus 2. Okay, so we are just basically dividing it by 8. So this minus and this minus will become plus. Okay, so x by 2, y by 1, z by minus 2. What is the corresponding eigenvector for this? That is 2, 1 and minus 2. Similarly, we are just going to substitute lambda is equal to 15 and we are going to find the corresponding eigenvector. So now we are in the last case, that is lambda is equal to 15. If I substitute in the given equation, remember what was the first one? 8 minus lambda, that is 8 minus 15. So I got minus 7x. And then other two values are same, and here it is same. And second diagonal element was 7 minus lambda. So 7 minus 15, so I have written minus 8 here. And then these two values are same, and finally 2 and minus 4 are same. And here you remember in the master equation, that is 3 minus lambda, that is nothing but 3 minus 15, so minus 12. So you have to refer equation 1 and substitute lambda as 15 in that. So you'll get these equations, and we have to find x, y, z by the method of cross multiplication. So what is the first value? Remember, leave this x column as it is. I've marked in red. What are the coefficients? Minus 6, 2, and then minus 8, minus 4. Okay. And now what you're going to do? Leave this y column. Okay. Now we are going to write the rest of the coefficient. I'm just going to mark this y column in yellow. It means you're not supposed to take values from that column. What are the leftover values? From the first two equations, minus 7 plus 2. Minus 7 plus 2. Leftover values, minus 6, minus 4. And finally, we are in z. Leave the z column. So I haven't marked anything. So if you see here, minus 7, minus 6, and then minus 6, minus 8. Minus 7, let me take minus 7, minus 6, and minus 6, minus 8. Okay, so we are done with this, and we are going to simplify this. So minus 6 into minus 4, that is 24, minus 8 into 2, so 16. So this minus and this minus will become plus 16, and minus y by minus 7 into minus 4, 28. This minus and minus will become plus, minus 6 into 2, so you'll get minus 12. So this again will become plus 12, and finally z by minus 7 into minus 8. Okay, that is 56, minus 6 into minus 6, it will become plus 36. So that is we'll get x by 40 is equal to minus y by 40 is equal to z by 20. So if you divide it by 20, what you will get? 2 minus 2, 1. So the corresponding eigenvector is 2 minus 2 and 1. So this is the eigenvector corresponding to lambda is equal to 15. So this is the corresponding eigen vector, that is 2 minus 2, 1 for lambda is equal to 15. So we got all the values, that is lambda 0, we got an eigenvector for lambda 3, again another one, and lambda is equal to 15. Now remember that you can solve these equations, and when it comes to factorization, you can use synthetic division also to solve the given polynomial. So for each eigenvalue there exists a corresponding eigenvector. Thank you.